Hello students, this is the fourth lecture of travelling wave equations in a power system, right? Now we will see in the fourth lecture what are the various protection schemes in a power system. In the previous lecture what we people have studied, we study about the effect of the termination of line with line parameter as well as we study about the Believilless lattice diagram. In this lecture we people see protection and their types, impact of voltage over a protection schemes and the lightning and its effect, right? Now what is the need of protection and what is protection? The objective of power system protection is to just isolate the faulty section. So many faults are there, it may be symmetrical, it may be the unsymmetrical, it may be open circuit fault, it may be a short circuit fault. Just to isolate the faulty part from a live system so that the system will become healthy, right, and will continue without any damage. So we have a two type of faults. Few people say that we have a over voltage under voltage faults, or we have over voltage under voltage protection schemes. Few people say we have a over current and under current. But in this section we people have to study about internal type of protection and external type of protection. Now what is the internal protection? Internal protection is the protection of a device, like we want to protect a stator, we want to protect a rotor in their windings, the transformer, their temperature, their windings, their oil concentration, the loads connected and so on. In the external protection we basically focus over the transmission line, substation, distribution section, etc. Right? Now what is system protection? A system protection is an art and science of detecting problem with a power system components and isolating these components. Now why we people need to isolate these components? We need to isolate these components because we want to make our system healthy during the fault time, right? Now what is the purpose of the protection? The purpose of protection is to protect the public so that there must be not any accidental case, to improve the system stability so that during any fluctuation like over voltage, under voltage, sudden removal of the load, sudden addition of a load over a system will does not disturb the stability of the system, minimizing the damage to the equipment connected for the protecting the system, like we didn't want to damage our relay, isolator, circuit breakers and other protecting devices. Protect against overload, as I already told that we have a overload, underload, so we want to protect our system, and basically we want to protect the alternator, the transformer and the transmissions line, right? Employ relay tech and engineers. Now the protection scheme also want to improve the various technologies which will be used for the relaying of a switches, switch gearbox, etc. Now what is the cause of over voltage in our power system? Basically there are two type of causes in a power system over voltage. The first one is external, another one is internal. In external there may be a direct lightning stroke, there may be electromagnetic induction. Due to this lightning stroke there may be a voltage induced due to atmospheric changes. Atmospheric changes means thunderstorm, heavy wind, heavy rainfall, like this. Electrostatic induced voltage due to presence of charged particle or a clouds nearby. So this type of situation occur in a hilly areas where the cloud always spread over a conductors near the tower of a transmission line, etc. And electrostatically induced over voltage due to frictional effect of small particles like dust, dry snow. Also these type of things are happen in a hilly area, in a mountain region, or in a the dust will appear in a desert area, right? These are the atmospheric conditions. So for protection due to which the over voltage may happen in a power system. Now in the internal there may be a switching operation of loaded or unloaded line. There may be an unloaded line, we want to switch, it means we want to connect it the sudden opening of a loaded line, the line is already connected and suddenly it is open. It may be due to open circuit fault, it may be due to the short circuit fault. Then failure of the insulation, this is the major cause. Failure of insulation, we have already know we have a several class of insulation, A, B, C, D and so on. We want to just control the insulation failure, and in our power system we always calculate the value of current just only to minimize the insulation failure of the system, right? Arcing grounds and the resonance due to several harmonics present in a power system. As you see, these are the arcing, these are the surges which are appear during connection and opening of a bus bar or opening of a terminals, opening of isolators, etc. Right? Now what is the lightning and its mechanism? As we see that lightning is very common during the rainy season. The lightning, what is lightning? Lightning is an electric current. It is a group of charge, right? It is a bright flash of electricity produced by thunderstorm. It is very dangerous, right? It is a sudden flow of electric charge from one point to another. Basically it is a electric charge, or we can say that it is a potential gradient, and its value will comes in a several kilowatts, right? The charge region is available due to the atmospheric condition. This is due to the atmospheric condition of a system, right? What is the flash? The object which is strike, when it is strike over a discharge object, then there is a flash or there is a sparking near the metallic body, right? Now what is the mechanism of lightning? This is very important. How a lightning creates in atmosphere. As we know that our atmosphere is divided into several spheres: atmosphere, ionosphere, ozonosphere, stratosphere, troposphere. In these spheres, the ionosphere is a region which contains a positive as well as the negative ions. These ions always attract and repel with each other. Suppose there is a negative ion region in a cloud. If you see here, they collect to become a very big. There is a electric field intensity induced, and if the ground is created as a positive, then when the cloud comes near to the ground region, or we can say that when the cloud density is increased and the distance between negative ion as well as the positive ion is very short, then the potential gradient will suddenly increase, and its value may be up to 10 to 30 kilovolt per centimeter. This is very high value, right? And this is always happen during the thunderstorm, during the rainfall, during the lightning, right? Now what is the wave shape of these thunderstorm? The general value of thunderstorm is very less, and it cannot impact the human, but during the lightning process its peak value increases, and this value increases, though it increases for a very short time, but its value is very high. It may be in a kilo ampere. If you see here parameter, it is a kilo ampere. Now what is the type of lightning stroke? If you see here, the direct and the electrostatic. Direct means the cloud discharge through a metallic body directly without any bypass path, and in electrostatic induction, the charge, one group of cloud or a charge induced with another, and this will combine with another, and then it will be strike to any metallic part or any ground region, right? Now over voltage due to lightning. When lightning occurs any transmission tower, we must have to protect that transmission tower with a shield wire. Shield wire is a topmost wire which is kept over any in all transmission sections. What is the mechanism behind it? Because the lightning contains several charges, Q is equals to CV, and the capacitance between this wire and a ground is of a certain value, like suppose it is a capital C, then definitely it contains some type of voltage. This voltage, when compiled with a voltage connected in a transmission tower, becomes an over voltage due to the lightning section. This E is basically electric field intensity, right? So we have to prevent the impact of over voltages due to lightning over a transmission tower. and for protection of it we have to provide a shielding. These wires are known as a shielding wire, right? Now what is the impact? This is again an important factor. What are the impact of a transmission line, lightning stroke over a transmission line? The first case, when a difference between potential difference increases, then there is excess of a charge appear, excess of the charge appear at a transmission section, and excess of a voltage. Now what are these consequences of over voltages or a lightning over a transmission line? The insulation failure. In this section, the insulation failure, like a puncture of insulators connected to balance the potential gradient of transmission line. Suppose these are the string of insulator which we have already studied in a previous semester. The second case of over voltage is by lightning and shielding wire and the striking of a conductor over a shielding failure. We must have to see about the bypass of a shielding. If the lightning stroke does not appear at a shielding wire and it directly hits the conductor of any line wire, suppose this or this, then it will create a very big damage to the transmission section. It is based on a transmission line position also, that what is the height of a transmission line, what is the inclination of the insulator, which type of insulator we people use, suspension or the cycle type, right, or a V string, like these. But the most important thing is, it is also very important to increase the light and withstand level of insulator. So the level of insulator or the counting of the insulator are also important, and that material of the insulator which we people use, that is porcelain or a glass. Glass is more superior, porcelain is cheap and easily available string of the insulator. And the grading rings. Grading rings, if you see here, these type of rings which we people use. The most important thing is that what are the favorable conditions. Favorable conditions are basically the environmental conditions. If these are good, then we didn't have to much problem for a impact of lightning. If these are bad, then we have to face several problem over the impact of the lightning stroke, right? Now what is the basic design requirement for the protection against lightning? We have to focus over these 4 points. The first point is the ground wire. It means we have to use a good ground wire that should be mechanically strong as well as provide sufficient shielding. There should be a sufficient clearance between power conductor and the tower. It means the height of tower and the ground should be properly balanced. It contains a high potential, the ground controls always a low potential, right? So there must be a good electric field difference, right? There should be adequate clearance between line conductor and the ground. It means if you see here, we people have already see here, I am talking about this line conductor and the ground, particularly mid of the span. We people know that, suppose this is the one tower, this is another tower. Now what is the sag and span? Like this, right? Height from the ground to a live conductor, right? The tower footing resistance, this is very important, the grounding resistance of a tower, which we people have to see in the next section, right? Now protection of power station and substation from the direct lightning. This is the indirect over voltage stroke. Now an object in a good electrical connection with the earth, so that leader stroke may be get attracted. Suppose this is point 1. What is the consequences? The upper portion of a metal structure may be employed. Alternately, separate metallic system, often called a shield, may be used. We have already seen what is a shield. Particular shield configuration in a form of mast, overhead, ground wire is considered to be provide good shielding, right? A low impedance path joining. Why we are talking about low impedance? Because current always passes from low impedance path. If the low impedance is provided between a ground and a conductor, then definitely during the lightning, the all kiloampere or the ampere suppressed towards the ground directly due to the low impedance of the system. It may be a low resistance, it may be a low reactance, but the material should be free from a corrosion, because it has to be dig under the ground, right? Its cross section area must be properly, because resistance is equals to R is equals to rho L upon A. So all these three parameters must be kept in a mind before designing any internal resistance. A low resistance connection of our earth body is very important. If we do not follow these relationship, or we do not follow these pattern, then it may be possible there might be a very big accidental in a substation or in a power station. Now if you see, this is a indicative diagram of our power system. There is a control room, all the equipments are connected with a ground like this. Okay. Then there are internal joints of copper cables which are used to protect a ground with a live conductor. This is copper bonded rods, and this is type of zigzag connection which we people use. This is a crushed rock. This is important, and you have to identify why we people use crushed rock in a substation. Just go and search in a Google. It is very interesting, right? Now this is transformer. Its external body is also earthen. Its coolant part is also earthen, right? EHV transmission coming from a outer tower. We have already seen such type of connection in a substation. Each and every equipment and the fences, each and everything is connected with a ground. Such type of thing is also seen in our college, that in a workshop all the equipment are connected from wall to wall mounting ground, and this is very necessary, right? Okay, in a next section of this continuing video, we will see about the protection of transmission line as well as the protection of the equipment. So be in touch. Thank you so much.